Okay, so we're just doing another quick RoboSub testing video here. Later today we're going to actually do the test this is for, but this is a sensor test. I've got Arduino's serial plotter. Let me show you the side there so you can see the scale. Running a 13-bit ADC on the Teensy, on the Teensy 3.1, and it's got a 2 millisecond delay between samples, and the blue is an average of 20 samples, so it's 20 samples every 40 milliseconds. This is a TMP36. The datasheet's actually backwards. Ground and VCC switch places, and that's just running onto A ground. Let's see, what is it? A ground, VCC, A9, something like that on the TC pinout, right into some wires, and you might be getting a little signal noise on all those wires. We'll fix that if we end up using these in the sub, or we might just use digital sensors of significantly higher quality than this little tiny $2 cheapie off Amazon. But it's shipped in one day, and so we'll take it. This is for testing the internal temperature of the hull if we put a 60-watt incandescent bulb in it, which will simulate the heating of GPU and CPU in an enclosed chamber. And we're just testing the data stability off this, so running in exactly what I'm showing you. You're watching the data feed. It's averaged around a convenient 1800 on the side there. Max peaking around 1840, so that's 40 counts. I'll do the math later when I post this. And 40 counts down, give or take. But the data stability is within, I want to say like 5 or 10 counts plus minus. And then if you just, hold on, let me do this so you can see stuff happening. If I hold the sensor between my fingers, then it goes up. And the average across 20 samples, so a sample update every 40 milliseconds, which is pretty good, is tracking pretty cleanly. It goes up really quickly, it takes a lot longer to cool down, so if I let go of it, you're going to see it track back down, but not nearly as quickly as when I first touched it with my finger. It actually says that stuff like this on the datasheet. The forced air reaction rates are much higher, and we're going to have this thing in a tube with a 60-watt bulb and a couple of computer fans, so there should be a lot of forced air around it. So we're expecting rise times within 5 seconds, but if we're tracking fall times, you might have, like 60 seconds, a couple of minutes of lag, something like that. Forced air should be a little bit faster. I don't know what happened there. That's kind of weird. Does it have to do with that? Not really. Just caught up. I don't think there's, if I blow on it, it's not significantly cooler than ambient, so that doesn't help. That's kind of doing nasty stuff with the min-max. Or, oddly enough, so this should be the minimum. And it's getting more affected. It looks like it's a little bit more peaky than the maximum. And there might be something like where we take the minimum and the maximum per average, and we use those, and we take the value nearest the minimum and the value nearest the maximum, and we subtract those out of the window, and then we average that. And I think that's what I'm going to try next, and like select the nearest values, and that should get the average a little bit cleaner.